If your lawn is still waiting for spring to become impressive, you are already late because the decisions you make before September can determine whether next season begins with dense green turf or a battlefield of weeds, bare soil, insects, and expensive repairs. Welcome to Blueprint Backyard, where we turn backyard problems into practical systems that work with biology instead of fighting it. Today, we are taking the 6 jobs shown in this checklist: weed control, soil pH, patch repair, pest management, mowing, and feeding, and turning them into a precise late summer lawn reset. The goal is not temporary green color. The goal is stronger roots, better soil structure, fewer competitive weeds, and a routine that can be measured, repeated, and eventually automated. Start with weeds, because every weed is competing with desirable turf for light, water, minerals, and root zone space. But the real objective is not simply to kill weeds, it is to remove them without damaging the grass you are trying to protect. That begins with identification. Broadleaf weeds such as dandelion, plantain, and clover behave differently from grassy weeds such as crabgrass, goosegrass, and annual bluegrass. A selective herbicide designed for broadleaf weeds can injure turf if the grass species is incompatible, while a non-selective product can damage almost every green plant it contacts. Before using anything, read the active ingredient, turf species listed on the label, application rate, temperature restrictions, and re-entry instructions. The biology explains why timing matters. Herbicides must be absorbed in sufficient quantity, and for systemic products, transported to tissues where they disrupt plant growth. A rapidly growing weed may respond differently from a drought-stressed plant. Perennial broadleaf weeds can be easier to suppress when they are actively moving carbohydrates toward their roots before dormancy. Annual grassy weeds may require a different strategy, because prevention before germination can be more effective than trying to eliminate an established plant after it has developed a mature crown and root system. Before spraying, walk the lawn in a grid and map the problem. Every few steps, identify the weed, estimate its density, and look at the surrounding conditions. If weeds are concentrated along compacted paths, traffic may be creating the opening. If they dominate thin turf, the underlying problem may be poor density or inadequate sunlight. If they occur in wet depressions, drainage could be the real issue. Herbicide can remove the visible symptom while leaving the ecological opportunity that allowed the weed to establish. Your long-term objective is therefore competitive turf, not permanent chemical dependence. For spot treatment, calibrate the sprayer instead of guessing. Mark a known area, apply plain water while walking at your normal pace, and measure how much water the equipment uses. That tells you the application volume for that walking pattern. Then calculate the product according to the label's area-based rate. Never increase concentration because you want faster results. Overapplication can injure turf and increase runoff risk. Avoid spraying in conditions where wind can move droplets into vegetable beds, ponds, drains, or neighboring plants. Do not treat severely heat-stressed or drought-stressed turf unless the label permits it. If weeds survive, do not immediately double the dose. Confirm the species, active ingredient, coverage, weather, and required treatment interval first. Next comes the number that quietly controls much of what happens underground: soil pH. Think of pH as a chemical traffic controller. It influences nutrient solubility, microbial activity, root development, and the availability of elements such as phosphorus, iron, manganese, and aluminum. A lawn can receive plenty of fertilizer and still show deficiency symptoms if soil chemistry prevents roots from accessing those nutrients efficiently. That is why adding more fertilizer to pale grass without testing the soil can be like filling a leaking tank. Do not estimate pH from grass color. Test it. Collect multiple soil cores from representative parts of the root zone, avoiding fertilizer spills, compost piles, driveway edges, and recently amended areas. Follow the laboratory sampling instructions and request pH along with nutrient levels and organic matter when available. The appropriate pH range depends on the turf species and soil, so do not blindly chase one number.
Many turf systems perform well in mildly acidic to near neutral soil, but a laboratory recommendation is more useful than a generic chart. If the test indicates acidic soil, lime may be recommended. But lime is not fertilizer and more is not better. Agricultural lime neutralizes acidity and supplies calcium, while dolomitic lime also supplies magnesium. The appropriate amount depends on soil texture, current pH, buffer information, and the material's neutralizing value. Sandy and clay soils can respond differently. Now examine the brown patches. The checklist promises quick repair, but the first question should be, why is the grass brown? A patch can result from drought, fungal disease, insect feeding, animal urine, mechanical damage, buried debris, compaction, poor drainage, herbicide injury, or previous stress. Seeding a patch without diagnosing the cause is like repainting a warning light. The surface changes, but the failure remains. Use your hands and a small trowel. Check whether the soil is dry below the surface. Examine roots for density, firmness, and discoloration. Look for excessive thatch, fungal signs, damaged roots, and compacted soil. If insects are suspected, inspect the transition between healthy and damaged turf rather than randomly digging. If disease is suspected, record recent weather, irrigation frequency, mowing height, and the time of day when symptoms appear. Those details can reveal more than the color of the patch. Once the cause is corrected, repair the physical structure. Remove dead vegetation and loosen the upper soil without destroying surrounding roots. If the area is compacted, core aeration can create channels for air, water, and roots. But do not aerate waterlogged soil or extremely dry soil that equipment cannot penetrate. For small areas, a hand cultivator or garden fork may be enough. You want a stable seedbed with good seed-to-soil contact, not pulverized soil. Choose repair material based on the turf already growing there and the site's conditions. Matching species improves appearance, mowing behavior, and long-term competition. Cool season grasses should be seeded during their appropriate establishment window, while warm season turf may require different timing or vegetative repair using plugs or stolons. Do not copy a September schedule from another climate. September can be an excellent establishment period in one region and severe heat in another. For small seeded patches, distribute seed in 2 perpendicular passes instead of dumping it in one direction. Lightly rake the seed into the surface and keep the upper layer consistently moist without creating puddles. Emerging seedlings have tiny root systems and little tolerance for drying. Once seedlings establish, gradually increase the interval between watering while applying enough water to encourage deeper root exploration. Constant shallow irrigation can create fragile surface roots and favorable conditions for disease.
The next category is pests, and this is where many homeowners treat far too aggressively. Grubs, ants, mosquitoes, and other insects have different life cycles, habitats, and control strategies. Integrated pest management begins with identification and monitoring. You are not trying to eradicate every insect, you're trying to keep damaging populations below an acceptable threshold. For white grubs, first confirm that larvae are actually present at a damaging density. Pull back a small section of turf near the edge of the damaged area and inspect the root zone. Count larvae instead of assuming that 1 or 2 indicate a serious infestation. Identification matters because different grub species have different biology and may respond differently to control measures. Treatment timing matters as well, because some insecticides work better against certain light stages than others. Follow the product label exactly, including any irrigation instructions needed to move the treatment into the root zone. Mosquito management is primarily water management. Inspect containers, clog gutters, plant saucers, block drains, tarps, wheelbarrows, and low spots that retain water for several days. Mosquito larvae develop in standing water, so removing breeding habitat can be more effective than repeatedly killing adult mosquitoes. Where water cannot be eliminated, only use products labeled for that specific situation and follow all directions. Your lawn itself is usually not the main mosquito nursery. Drainage and water-holding objects are more important. Now, consider mowing, the apparently simple task that can either strengthen turf or repeatedly stress it. The key is a relationship between mowing height, growth rate, leaf area, root energy, and clipping return. Grass blades are photosynthetic organs. Removing too much tissue at once reduces photosynthetic capacity and forces the plant to spend stored resources recovering. Removing a reasonable amount allows the plant to maintain a productive canopy. That is why the one-third rule is so useful. Avoid removing more than roughly one-third of the existing leaf height in a single mowing. If the grass has become excessively tall, do not scalp it in one pass simply to reach the desired height. Lower the height gradually over multiple mowing cycles. Scalping can expose crowns, increase soil temperature, reduce root reserves, and create openings for weeds. On the other hand, mowing excessively high can produce a floppy canopy and poor appearance if the species is not adapted to that height. The correct mowing range depends on turf type, season, shade, irrigation, and local conditions. Your mower is part of the biological system. Sharpen the blade regularly, clean the deck, and check that the mower maintains a consistent height. If stripes of different height appear, inspect deck leveling, tire pressure, wheel settings, and overlap before changing fertilizer. Return grass clippings when practical and when mowing is frequent enough to keep them small. Clippings contain water and nutrients that can cycle back into the soil. They do not normally create thatch simply because they remain on the lawn. Thatch is mainly made from slowly decomposing stems, crowns, and roots. If large clumps remain after mowing, their grass was probably too tall or wet, or the mower needs adjustment. Finally, feeding. The checklist mentions a cheap powder schedule that replaces fertilizer, but price does not determine nutrient value. Plants require essential elements in specific quantities, and turf response depends on soil reserves, species, growth rate, and environmental conditions. A fertilizer program should therefore be based on measured need rather than marketing claims. Nitrogen deserves special attention because it strongly affects leaf growth, color, and canopy density. Too little nitrogen can produce thin, pale turf with weak competitive ability. Too much can create rapid, soft growth that demands frequent mowing and may be more vulnerable to environmental stress. Smaller, measured applications can be more useful than one excessive dose, depending on the turf and season. Soil testing can guide phosphorus and potassium decisions, while nitrogen planning depends heavily on turf species, expected growth, clipping return, and local conditions. Be careful with homemade fertilizer substitutes. Compost, manure, coffee grounds, molasses, and other household materials may contribute nutrients or organic matter, but their nutrient concentration is variable. Applying them by volume without understanding nutrient content can create uneven fertility, salt problems, weed seeds, or nutrient runoff. Compost is valuable when mature and properly produced, but it is not a mathematically precise replacement for every fertilizer requirement. If a product claims that a tiny amount of inexpensive powder can replace conventional fertilizer, ask what nutrients it supplies, at what concentration, and how much reaches the root zone per square meter. Calculate nutrients delivered rather than judging effectiveness by the size or price of the package. This is where automation becomes useful. Build a simple lawn dashboard. Record turf species, mowing height, rainfall, irrigation duration, soil test results, fertilizer applications, weed pressure, pest observations, and patch locations. A spreadsheet can reveal trends that memory misses. A soil moisture sensor can reduce unnecessary irrigation, while a rain gauge can prevent the controller from watering immediately after substantial rainfall. Automation should not replace observation. It should make good decisions easier to repeat. For irrigation, focus on the root zone rather than the surface. Frequent light watering can keep the top few millimeters damp while leaving deeper soil dry, encouraging shallow roots. When established turf needs water, aim for thorough wetting of the active root zone, then allow the surface to dry appropriately between irrigation events. The exact schedule depends on soil texture, weather, shade, turf species, and evapotranspiration. September is also a useful checkpoint for compaction.
Heavy traffic destroys pore space, especially when soil is wet. Roots need oxygen as well as water, and compacted soil reduces air-filled porosity. If water ponds after ordinary rainfall, investigate compaction and drainage before simply increasing irrigation. Core aeration can relieve compaction and suitable turf, but timing should match active growth and appropriate soil moisture. Now combine the checklist into one sequence. First, diagnose. Walk the property and map weeds, thin areas, brown patches, standing water, pest evidence, and compacted zones. Second, test. Collect soil samples and measure pH rather than guessing. Third, correct the limiting factor. Adjust pH only when justified. Improve drainage, reduce compaction, and remove obvious mosquito breeding sites. Fourth, control weeds and pests selectively, using identification, timing, and label-based rates. Fifth, repair damaged turf with compatible seed or vegetative material. Sixth, mow according to growth rate and turf species, maintaining sharp equipment and avoiding excessive leaf removal. Seventh, feed according to measured need and seasonal demand. Finally, record the results so next year's decisions are based on evidence. The most important troubleshooting rule is to change one major variable at a time whenever possible. If your lawn is yellow and you simultaneously add nitrogen, lime, iron, compost, extra irrigation, and pesticide, you will not know which intervention helped. Diagnose the likely constraint, make the smallest appropriate correction, and observe the response. If a repaired patch dies again, do not simply reseed it. Ask what killed it. If seed never germinates, check seed to soil contact, moisture, temperature, seed quality, and competition. If seedlings emerge and disappear, investigate drying, disease, birds, insects, and mowing damage. If the lawn becomes greener but remains thin, nitrogen may have improved color without solving sunlight, compaction, density, or root problems. If weeds return from the same location, the site is telling you something about its underlying conditions. That is why the most expensive mistake is often not buying the wrong product, it is solving the wrong problem. A homeowner sees yellow grass and buys fertilizer. Another sees brown patches and buys fungicide. Someone sees ants and sprays everything. Someone sees dry soil and increases irrigation without checking drainage. Each action feels productive, but without diagnosis, the lawn becomes a chemical and mechanical tug-of-war. Your September reset should therefore be precise. Carefully identify the turf, identify the weeds, test the soil, measure moisture, inspect roots, check mowing height, look for pests, correct compaction and drainage, apply only what is justified, then document the response. This may sound slower than spreading a product everywhere, but it is faster in the long run because every action has a reason and every result teaches you something. Use thresholds rather than habits. Water because the root zone has reached a moisture threshold and the forecast does not provide enough rainfall. Do not fertilize because the calendar says September. Fertilize because the turf species, soil condition, growth stage, and nutrient plan justify it. Do not spray because you saw one insight. Act when monitoring confirms a damaging population or when preventative timing is justified. Threshold-based management turns a backyard into a controlled biological system instead of a collection of repetitive chores. You do not need expensive technology to start. A notebook, soil test, sharp mower, calibrated spreader, rain gauge, moisture sensor, and disciplined observation can outperform a garage full of random products. If you remember one principle from this entire reset, remember this. Healthy turf is not created by doing more things. It is created by removing the conditions that prevent the right things from happening. Give roots oxygen. Give plants the right moisture. Give soil the chemistry they can use. Give the canopy enough leaf area to photosynthesize. Give seedlings contact with soil. Give pests a threshold instead of automatic chemical warfare. Give every treatment a measurable reason. September is not simply another date on a gardening calendar. It is a strategic checkpoint. The work you do now can reduce the number of problems you inherit later.
Pulling weeds before seed production, correcting pH before repeated nutrient applications, repairing patches before they expand, monitoring pests before populations explode, adjusting mowing before stress accumulates, and feeding according to actual demand all move the lawn toward resilience. So before September disappears, walk the lawn and ask 6 questions. What weeds are present, and why are they winning? What does the soil test say about pH and fertility? What caused the brown patches, and has that cause been corrected? Are pests actually present at damaging levels? Is the mower removing the correct amount of leaf tissue? And does the feeding plan match what the turf can actually use? If you can answer those questions with measurements instead of guesses, you are no longer treating the lawn as a mystery. You are managing a living system. Do the diagnostic work now, make precise corrections, and let biology carry the system forward. This is Blueprint Backyard. And if you want more practical gardening systems that turn ordinary backyards into resilient, productive landscapes, stay with us. The best backyard is not the one that demands the most work. It is the one designed so every smart action makes the next season easier.